Hello everyone, I am Dr. P. Kumari, working as Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. So today in this video, I am going to discuss about general solution of non-homogeneous equation, method 2. So what is the meaning of method 2 is, here based on the Q of x value, RHS part, different values will be there. Based on that, we are dividing the methods here. So in the previous video, we completed method 1, that is Q of x equal to e power x. So those who want to know about the method 1, please go through that video. So now we are going to discuss about method 2. So what is the value for the Q of x? We are going to see here. First of all, solving the linear differential equation with coefficients, constant coefficients is here. The complete solution of the equation is in the form f of d into y equal to f of x. For that, you can replace here q of x also. In the sum notations, we are denoting with q of x, and in some textbooks, we are denoting with f of x here. The complete solution of this equation is ci plus p, cf plus pi. What is the meaning of CF is complementary function and PI is particular integral. So for the non-homogeneous equation, we have to calculate both values, complementary function and particular integral. For the homogeneous, only complementary function is enough here. So here in this, we are going to discuss about non-homogeneous equation. That means our complete solution is complementary function and particular integral. So here based on the q of x value, we are deciding the methods. So in the first method, q of x value in the equation f of d into y equal to q of x or f of x. Q of x value is e power ax. Then how to solve that given equation? Otherwise, how to calculate the particular integral value? So that is the method 1. So now we are taking here in q of x sin ax or cos ax. So if you are having sin ax or cos ax, how to calculate the particular integral? This is method 2. So if you are having x power k or x power m or x power n, so how to calculate particular integral? That is, we are taking as method 3. And so if we are having q of x value e power ax into v. So what is the meaning of v here? In place of v, we can have sin ax or cos ax or x power k. So these three values we can have in place of v. So this is method 4. So now we completed method 1. Now today I am going to discuss about method 2. What is the method 2? In place of q of x or f of x, we have sin ax plus p or sin ax, cos ax plus p or cos ax. How to calculate the particular integral? So complementary function is as it is. There is no change in the procedure of the complementary function. So here we are changing the procedure and method for the particular integral based on the q of x value or f of x value. So here, so f of x or q of x value is sin ax or cos ax. Then what is the procedure we are going to follow? First step, we have to replace d square equal to minus a square. So here we should have first we have to calculate the a square value, then put minus. So some are thinking that minus a whole square will be plus a square, right? So don't take like that. So here a square minus a square, you have to replace minus a square value. So here d is nothing but a by dx, and in place of d square we have to replace the minus a square value. So here this is the first step. So here f of minus a square should be not equal to 0 after replacing the value here. If f of minus a square is 0, what we have to do? So for the particular integral, if f of minus a square is 0, Then we have to follow this procedure. We are having the formulas here. Sin ax by f of t. So in place of f of t, we can have the form d square plus a square into pi of d square. So here in place of d square, we are replacing minus a square, right? So pi of minus a square into d square plus a square. So finally, here we can replace minus x by 2a cos ax. If you are having here sin ax, so we should have x minus x by 2a cos ax. For example, if you are having cos ax here, then x by 2a sin ax. These are the formulas. If f of minus a square equal to 0, then sin ax by f of d is equal to 1 by pi of minus a square x by 2a cos ax minus x by 2a cos ax. Here pi of minus a square should be not equal to 0. So like this, if you are having cos ax here, so cos ax by f of d is equal to what by pi of minus a square x by 2a sin ax. Sin ax. Here also pi of minus a square should be not equal to 0. So these are the two formulas we are going to follow if you are having f of minus a square is equal to 0. So according to this procedure, we are going to solve some of the problems here. Please observe. First of all, see this example. Solve the differential equation. Solve the differential equation. What is the differential equation? D square plus t minus 2 into y is equal to sin ax. Here d square, given equation is d square plus d minus 2 into y is equal to sin x. Now I am comparing with the general equation, that is f of d into y is equal to q of x. Now what is the f of d value? F of d is equal to d square plus t minus 2 and q of x value is nothing but here sin x. So now we have the value here sin ax form. So that means we can follow the procedure method 2. So first of all, here what is the general solution of the non-homogeneous equation? Y equal to yc plus yp. What is the meaning of yc? Yc is complementary function plus what is the yp? Yp is particular integral. So first I am going to calculate the complementary function. So complementary function we are calculating. So for the complementary function, first we have to write the auxiliary equation. What is the auxiliary equation here? Auxiliary equation is f of m equal to 0. So that means in place of d we are going to replace m value. So m square plus m minus 2 equal to 0. Now I am going to write the factors here. M square plus 2m minus m minus 2 equal to 0. Take m common here. M plus 2 into here minus 1 into m plus 2 equal to 0. So now m minus 1 into m plus 2 is equal to 0. So m equal to 1 comma minus 2. So m values are 1 comma minus 2. That means m1 equal to 1 and m2 equal to minus 2. So according to these roots, we are going to calculate the complementary function. Here these two roots are real and distinct. So complementary function yc equal to c1 e power ax. That means e power ax is m1 value. So m1 value is 1 into x plus c2 into e power m2x, that is minus 2x. So this is our complementary function. So first step is completed. So now after calculating the complementary function is completed, that is c1 e power minus 2x plus c2 e power x. So now we are going to calculate the particular integral. So here for the particular integral, based on the q of x value method we will have to follow. So q of x value is sin x. That means we have to follow the method 2. So first of all, what is the formula for the pi? Pi is 1 by f of d into q of x. So what is the f of d here? D square plus d minus 2 into what is the q of x value? Sin x. So here if you are having sin x, what is the procedure we have to follow? First put d square equal to minus a square. So here I have to replace minus a square in place of d square. So what is the a value here? A equal to 1. That means I have to replace minus 1 in place of d square. So now pi equal to 1 by, so d square is minus 1 plus d minus 2 sin x. Now finally 1 by d minus 3. So this is 1 by d minus 3 into sin x. So we can observe the value here. Now I am getting particular integral equal to 1 by d minus 3 into sin x. So after this, what is the procedure we have to follow? If you are getting like this with the d terms, we have to do the rationalization. So what is the rationalization I can do here? So d minus 3 into, here in the numerator we have to multiply with d plus 3 and denominator also d plus 3 into sin x. So finally here d plus 3 by a plus b into a minus b. So a square minus b square. That means d square minus 3 square. 3 square value is 9 into sin x. So finally this value is d plus 3 by d square minus 9 sin x. Now again I have to put the d square value is nothing but d square equal to minus a square. This value is minus 1. Now pi equal to d plus 3 by d square value is minus 1 and minus 9 sin x. So now, so d is nothing but d by dx. So derivative of dx. So d equal to derivative value, that is d by dx. We are going to apply here. So minus 1 by 10. So derivative of sin x plus 3 into sin x. So finally what is this value? Minus 1 by 10. So derivative of sin x is cos x plus 3 sin x. So this value is minus 1 by 10 cos x plus 3 sin x. That is only we can observe here. So this is the particular integral of the given equation. So already CF is calculated. So what is the complete solution or general solution? So general solution equal to y equal to CF plus PI. So complementary function already calculated, that is C1 e power minus 2x plus C2 e power x. And particular integral here minus 1 by 10 cos x plus 3 sin x. So this is our final solution, otherwise complete solution, otherwise general solution of the given equation. See one more example here. Solve the differential equation, that is d square plus 2d plus 1 into y equal to cos square x. First of all, what is the given equation? Write the given equation is d square plus 2d plus 1 into y equal to cos square x. Now here for this is in the form of f of d into y equal to q of x. So here q of x value is cos square x, and that means this is cos x or sin x form. We can follow the procedure method too. So here first of all, what is the general solution? So general solution is y equal to yc plus yp. So from this we can calculate, first we can calculate the complementary function, after then we have to calculate the particular integral. So how to calculate the complementary function? By using the f of t value. What is the f of t value? D square plus 2d plus 1. So from this we can write the auxiliary equation. Auxiliary equation is f of m is equal to 0. What is the f of m value? M square plus 2m plus 1 is equal to 0. So now I am calculating the factors here. So from this equation what we can write? So m plus 1 whole square equal to 0. So what are the m values? M values are minus 1 comma minus 1. So here we are getting the roots are equal. So based on that, what is the complementary function? Complementary function is C1 plus C2 into x into e power minus x. This is our complementary function. That means first step is completed. Now calculate the particular integral value. So particular integral equal to 1 by f of d into q of x. So what is the f of d value? 1 by m square. Sorry, here we have to write the d form, right? So d square plus 2d plus 1 into q of x value is cos square x. So now I can't calculate the cos square x value directly because I am having the form sin ax or cos ax form. So that's why I need to convert this value by using the trigonometric formula. So here to solve this problem, we should have some basic formulas. So that is differentiation formulas we should know, and integration formulas we should know, and trigonometric formulas also we should know. Then only we can calculate this type of problems. So here I am converting by using the trigonometric formulas d square plus 2d plus 1 into. So here in place of cos square x I can replace 1 plus cos 2x by 2. So here I can get the cos 2x, I mean cos ax form. So finally here 1 by d square plus 2d plus 1 into 1 by 2. So that is the first term, plus 1 by d square plus 2d plus 1 into cos 2a. This is the second term. That means I have to calculate particular integral separately for the each term. So for the what about the first term? First term 1 by 2 is the constant. Here I don't have any value. That means I can write this one as a e power 0x. That is d square plus 2d plus 1 e power 0x plus 1 by d square plus 2d plus 1 into cos 2x. Now here I have to follow the procedure for the method 1 because I am getting here e power ax form. For the second term I am having cos ax form. So we have to calculate particular integral separately for the each term. Finally here 1 by 2 1 by d square plus 2d plus 1 into e power 0x plus 1 by 2 d square plus 2d into cos 2x. Now put d equal to 0 in the first term. So here actually what is the a value? A value is 0. So here the procedure for the method 1 is we have to put d equal to a in the first term according to the e power x form. So that's why you have to put the 0 in place of d. And here for the second term we are having cos ax form. That means a value is 2. So here we have to replace d square equal to minus a square, that is minus 4 in the second term. Now we are writing the value here 1 by 2. In place of d we are replacing 0. So this total term is 1. So 1 by 2 I am getting here for the first term. Next for the second term 1 by 2 into 1 by, in place of d square minus 4. So minus 4. After simplification I am getting here 2d minus 3 into cos 2x. When you are getting only d term, we have to do here rationalization. So first term is 1 by 2 plus 1 by 2 into rationalization means I am going to multiply with 2d plus 3 with denominator and numerator. So 2d minus 3 into 2d plus 3 into cos 2x. Now what is this value? So 1 by 2 plus 1 by 2 into 2d plus 3 by a plus b into a minus b. So a square, that is 4d square minus 9 into cos 2x. Now the same procedure we have to follow here. So put d square equal to minus a square. So minus a square value is 4. So finally 1 by 2 plus 1 by 2 into 2d plus 3 by 4 into d square, that means 4 into minus 4 minus 9 into cos 2x. So finally this value is 1 by 2 plus 1 by 2 into here minus 16 minus 9. So here minus 25 and one more 2 also there. So this is minus 1 by 50 and 2 into derivative of cos 2x. So this is into 2 will come. So cos 2x is minus sin 2x plus 3 into cos 2x. So finally I am getting here 1 by 2 minus 1 by 50. So minus of minus plus 4 into sine 2x minus 3 into minus 3 by 50 into cos 2x. This is the value of particular integral. So finally, what is the general solution? So y equal to complementary function plus particular integral. What is the complementary function? C1 plus C2x into e power minus x, and particular integral finally we calculated, that is 1 by 2 minus 1 by 50 into minus 4 sin 2x plus 3 cos 2x. Now see one more example here. Solve the differential equation. What is the differential equation they given? D square plus 9 into y is equal to sin 2x into cos x. So here when I am comparing with the general equation, that is f of d into y equal to q of x. So f of d value is d square plus 9 and q of x value is sin 2x into cos x. Now according to this procedure, so I have to follow the method too. So first of all, what is the general solution? General solution y equal to yc plus yp. So what is the yc value? That is complementary function plus particular integral. So first I am calculating the complementary function. So for that I need auxiliary equation. What is the auxiliary equation? Auxiliary equation is m square plus 9 equal to 0. So m square plus 9 equal to 0. So m square equal to minus 9. So I can write the factors here, that is m equal to plus or minus 3i. And we got here complex roots. So complex roots means here m1 equal to 3i and m2 equal to minus 3i. According to this, I can write the complementary function yc equal to, here alpha value is 0. That means alpha plus I beta. In place of alpha, we are not having any value. That means 0. So e power 0x into C1 cos beta x. So C1 cos 3x and C2 sin 3x. So this is our complementary function. So after completion of complementary function, we have to calculate the particular integral. What is the formula for the particular integral? 1 by f of d into q of x. So 1 by f of d is 1 by f of d value is d square plus 9 into q of x value is sin 2x into cos x. So here we don't have the form like this, but by using the trigonometry formula, we can convert into our form what is we are having in the method 2. So here we can have this form 2 sin a cos b. So what is the formula for the 2 sin a cos b? 2 sin a cos b formula is sin a plus b plus sin a minus b. According to that, I am writing. So what is the formula for the 2 sin a cos b? 2 sin a cos b equal to sin a plus b plus sin a minus b. So according to this formula, I am writing here 2 sin 2x and cos x is equal to sin 2x plus x is sin 3x plus sin 2x minus x is sin x. So in place of sin 2 sin 2x cos x, I can write sin 3x and sin x. So now finally this is 1 by d square plus 9. I can write multiply and divide with 2. So that is 1 by 2 into 2 sin 2x and cos x. In place of this, I am replacing 1 by d square plus 9 and 1 by 2 is the constant. So in place of 2 sin a cos b, I can write sin 3x plus sin x. So now I am having the form like this sin ax. So now I can proceed to calculate the particular integral here. So now I am separating the term. So 1 by 2, 1 by d square plus 9 sin 3x plus 1 by 2, 1 by d square plus 9 sin x. Now I can calculate the particular integral separately. So particular integral 1 and particular integral 2, then add together to get the solution. Now we got the two terms, but we are following the same procedure. So now we are putting value d square equal to minus a square. In the first term, a value is 3. So that means here we have to replace minus 9. In the second term, a value is 1. That means we have to replace a square value is minus 1. Minus a square. So in the first term, d square value is minus 9. We have to replace. In the second term, we have to replace minus 1. So now equation becomes 1 by 2. So here 1 by d square plus 9. So here 1 by d square plus 9 sin 3x plus 1 by d square plus 9 sin x. Now here we have to put the value d square equal to minus 9 in the first term. So when you are replacing this value, here this value becomes 0. That means f of minus a square becomes 0. So in the first term. And in the second term, here minus 1. So 1 by minus 1 plus 9 sin x. So finally this value is 1 by 8 into sin x. So second term is calculated. What about the first term? If you are getting f of minus a square equal to 0, we have to write the formula. That is, here we are having sin ax means we can write here x by 2a cos 3x. So now I can write this value as 1 by 4 into x by a. And what is the a value? A value is 3 here. So x by 3 cos 3x. So finally I got first term is 1 by 12 minus 1 by 12 cos 3x, and for the second term 1 by 8 sin x. So this is the particular integral. So finally what is the complete solution? It's y equal to yc plus yp. So what is the yc value? c1 cos 3x plus c2 sin 3x plus here minus x by 12 cos 3x plus 1 by 16 sin 3 sin x. So this is the complete solution of the given equation. See one more example here to get the clarity about the second case, that is f of minus a square equal to 0. So here d square plus 9 into y equal to cos 3x. So d square plus 9 into y equal to cos 3x. So what is the f of d here? F of d equal to d square plus 9. As like a previous problem, we can calculate. The roots here according to the procedure. So what is the auxiliary equation? That is f of m equal to 0. That is m square plus 9 equal to 0. So m square equal to minus 9. So finally m equal to plus or minus 3a. So now we are having the complex roots. So complementary function equal to c1 cos 3x plus c2 sin 3x. So this is the complementary function. That means first step is completed. So here based on the q of x value, we are going to decide about the method. We are having the q of x is cos 3x. So that means we can follow the procedure method 2. So particular integral equal to 1 by f of d into q of x. So here 1 by f of d. What is the f of d value? D square plus 9 into cos 3x. So here what is the first step we have to do? So put d square equal to minus a square. That means what is the a value here? A value is 3. So minus 9 I have to replace. When I am replacing here minus 9 plus 9, so I am getting here f of minus a square is 0. So when you are having f of minus a square 0, we have to follow the formula. What is that formula here? Already we are having cos ax. So cos ax by pi of a value. So then x by 2 into a into sin ax, that is sin 3x. So x by 2 into 3. So 2 into 3 sin 3x I am having. So finally this is x by 6 into sin 3x. This is the particular integral value, and this is the complementary function, and this is particular integral value. Now finally, what is my general solution? General solution is yc equal to yp. We are adding together c1 cos 3x plus c2. This is sin 3x plus x by 6 sin 3x. This is the complete solution or general solution of a given equation. So this is the way to solve given non-homogeneous linear differential equation. For the method 2, that means what is the method 2? In place of q of x, if you are having sin ax or cos ax, for this we are going to follow this procedure. I hope you got the clarity about the solving of non-homogeneous equation by using the method 2. For the more examples, please refer these textbooks: Higher Engineering Mathematics written by B.S. Gravel and the textbook of Engineering Mathematics written by N.P. Bal and Manish Koyal, and Higher Engineering Mathematics written by B.V. Ramana. We can use one more textbook also, Engineering Mathematics written by T.K.V. Iyengar. Yes, Chand Publications. So we can refer these all textbooks to get more examples and to get the clarity about these methods. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.